For example, G and H, so we're going to be dealing with rational functions. So I'm going to give you sort of like steps here on how do we graph for rational functions. So it's going to be easier for you to get the idea of how the graphing is done. Okay, step number one is what we're going to do is we're going to find the intercept. So the x-intercept, y-intercept, if they actually exist, the intercepts actually exist. So you have to find them. And step number two is you're going to find the vertical asymptote. And how do we find the vertical asymptote? By simply setting the denominator equal 0. Okay, so whatever value that is not possible, so that is going to be the asymptote, vertical asymptote of the function itself. So let me correct the spelling. This is denominator. Okay, so step number three, after you have found the vertical asymptote, you're going to find the horizontal asymptote. So for horizontal asymptote, how do we find what is going to be the equation for the horizontal asymptote? There's sort of like a formula that you can actually apply, and the formula actually come from this basis right here. So what happens is that if you have a function equal ax to the power of n plus whatever the function that is at the back over bx to the power of m. So first of all, what you're going to do is you're going to identify what is going to be the highest power for the top and bottom. So n is going to be the largest power of the numerator, and m is going to be the largest power of the denominator. So if the value of n is bigger than m, for example, if you have something like this, so I have an equation of x squared plus x over x plus 1. So here my highest value is going to be 2 at the top, highest power is going to be 1 at the bottom. So this is going to be the case that, sorry, it's going to be, this is actually the other way around. So let me correct that. So for example, if I have some like x plus 1 over x squared plus x, so what happened here is that at the top my highest power is going to be 1, and at the bottom my highest power is going to be 2. So my n is smaller than m because 1 is smaller than 2. So y equals 0 is going to be the asymptote, just from the fact that we have n is less than m. So that is going to be the first situation. So the second is if the power of n and m is the same, so the power at the top and the bottom is the same. For example, you could have something like this. So you could have something like x plus 3 over x plus 1. So the line y equal a over b is going to be the asymptote. So what is going to be a? A is going to be the coefficient. Coefficient is the number right next to the variable. So of x to the power of n. So b is going to be the coefficient of x to the power of m. For example, if I were to refer back to the example that we have over here, so here my a value is going to be 1, my b value is also going to equal 1, so my y is going to be 1 over 1, which is going to be 1. So I'm going to have a horizontal asymptote at y equal 1. Okay, that is going to be for the second case. And for the third case, if n is greater than m, so meaning that you can have a higher power at the top than the bottom. So it's going to be the example that I've shown you before. Let's say if I have x squared plus 1 over x plus 3. So my power at the top is, highest power at the top is 2, highest power at the bottom is 1. N is greater than m, there will be no horizontal asymptote. Okay, so you don't have to worry about asymptote. So all you have to do is find the vertical. And of course, like after you have verified the intercept, vertical and horizontal asymptote, the last step is you're going to find some points in order to determine the general shape of the graph. So I will show you this later. So now let's proceed to our example. So which is going to be, I think it's already f now. So this is going to be f. So what's my function? So, oh, in fact, this is g. I have a negative 1 over x plus 2. So this is going to... Now let's start with the first example on rational function. So I have a function g, which is given by f of x equal negative 1 over x plus 2. So the first thing that I'm going to do is I'm going to find the intercept. So let's start with the y-intercept. And we know that we can find y-intercept when I set x equal 0. So when I set x equals 0, I will get y is going to equal negative 1 over 0 plus 2. So that is going to be negative a half. So my y-intercept is going to be at 0, negative a half. So that will be the coordinate. And then I'm going to do pretty much the same idea for the case of x-intercept. And x-intercept is when y is equal 0. So I'm going to set f of x equals 0 is equal negative 1 over x plus 2. And if I actually multiply this 2, so I'll end up with something that goes like 0 is equal negative of 1, so which is actually not true. Or, so basically what I'm going to end up is going to be something like this. So I can actually write this as x plus 2 is going to equal negative 1 over 0. And we know that this is going to be undefined because you cannot have anything that is being divided by 0. So therefore, undefined. So what does having undefined answer tell you? It's telling us that the x-intercept does not exist. So it does not exist. So therefore, we don't have to bother with the x-intercept. Okay, so now let's start with the other elements. So now we have already figured out the intercept. We're going to find the vertical intercept. So according to the notes up there, it's vertical asymptote. How do we find for vertical asymptote? We can find vertical asymptote when we set the denominator equal 0. So this is my denominator. So I'm going to set that equals 0. So I'm going to have x plus 2 equals 0. So x is going to equal negative of 2. So my vertical asymptote is going to be at x equal negative of 2. And the other one is going to be our horizontal asymptote. And how do we tell? So how do we find the horizontal asymptote? So it's going to be the rule that we have up here. So which concerns the value of n and also m. And the thing about the function that we have right here, so this is actually a negative 1x to the power of 0 over x to the power of 1 plus 2. So basically my n value is equal 0 and my m value is equal 1. So what happened is that, so my n value is less than m. So according to the rule, if n is less than m, so y equals 0 will be the asymptote. So therefore, my asymptote is going to be at y equal 0. Okay, so now let's sketch a little, just to sort of like get an idea. So how does the graph is going to look like? This is going to be my axis. So x and also f of x. So let's put the asymptote in red. So when you draw asymptotes, use a dotted line for it. So I'm going to start with x equal negative 2. For example, x equal negative 2 is going to be somewhere over here. So this is my x equal negative of 2. And my horizontal asymptote is going to be at y equals 0. So y equals 0 is going to be on the x-axis. So it's going to be right here. Okay, this thing is when we sketch for rational function is that we don't know where it's going to be the position, whether it's going to be on this side, on this side, on this side, or on that side. So what we can do is we can actually pick some points and try to figure out what's going on. Okay, for example, I can actually pick a point of x equal 1. So let me put my function first. My function is f of x equal negative 1 over x plus 2. So if I were to substitute f of negative 1, so I will get negative 1 over negative 1 plus 2, which is going to be negative 1 over 1, which is going to be negative 1. So if I were to find this point, so the point is going to be negative 1, negative 1. So let's say negative 1 somewhere over here. So negative 1 is perhaps going to be somewhere down there. Okay, and we know that we have our intercept point as well, which is going to be at 0, negative a half. So 0, negative a half is probably going to be somewhere over here. Okay, and if I were to find another point on this axis right here, for example, I can pick a value of f of 2. So I will get a negative 1 over 2 plus 2. So that is going to equal negative a quarter. So my coordinate is going to be 2, negative a quarter. So 2 negative a quarter is, let's say it's going to be 2, is perhaps going to be somewhere right there. So now what we can do is actually connect the lines. So my graph is going to look something like this. Okay. Alright, so on the other side, how is it going to look like? Sorry, it's going to be something like this. Remember, this is asymptote right there. So that's why it doesn't have it doesn't cross the x-axis, because we have an asymptote x to x-axis, and this side it's going to look something like this. It's going to be the opposite. When you sketch a rational function that looks like this, it's going to be the opposite. If you have one on this side, so the other one is going to be on the other side, unless it is some special cases like 1 over x squared and so on. Okay, so I'll explain that further when we come across other example. But if you can actually do the same, if you were to pick points, so you'll be able to figure out that this is going to look this way. Because for example, let's say if I were to pick a point of f of negative of 3, I'll get negative 1 over negative 3 plus 2, which is going to be negative 1 over negative 1. So that is going to equal 1. So negative 3, let's say it's going to be somewhere over here. So negative 31 is going to be somewhere over here then, let's say. Okay, so it's going to be further up. So if I want to make further up, so that's fine as well. So let's say this is going to be 1 just to match on this side. So my graph is going to look something like this. So it doesn't have to be exact, it's just a sketching, remember? So like we just want to know that basically, oh, this is how it's going to look like. All right, let me show you one more example on this. So the last one is going to be H. So what is my example? So it's going to be f of x equal 2 over 1 plus x. Okay, so the idea is still going to be the same. So my y-intercept is going to be y equal, sorry, it's going to be 2 over 1 plus 0, so which is going to be a 2. So the coordinate is going to be at 0, 2. So my x-intercept on the other hand is going to equal 0 equal 2 over 1 plus x is going to be the same as before. So the x-intercept does not exist for this case. Right? And then we're going to find the vertical and horizontal asymptote. So this is VA, I'm going to write it as vertical asymptote. So I'm going to have 1 plus x equals 0. And x is going to equal negative of 1. So this is going to be my vertical asymptote. And as for the horizontal asymptote, I'm going to use the same formula as I used previously. And here this is still going to be x to the power of 0 over x to the power of 1. So my n is still going to be less than m. So therefore my horizontal asymptote is going to be at y equal 0. So now I'm going to sketch down here. I'm going to make it bigger this time. So let's use black for the axis. Okay, so this is going to be my x. This is going to be my f of x. So for this case, I'm going to have the vertical asymptote at x equal negative of 1 here. Okay, so this is going to be x equal negative of 1. And again, my horizontal asymptote is going to be the same as previous example. It's going to be right on the x-axis. Okay, my intercept is going to be at 0, 2. So this looks pretty much similar to what we have before. So where is my 0, 2? So my 0, 2 is going to be perhaps somewhere up here. Let's see, this is going to be 1 and this is going to be 2. So remember previously our example, it goes here and this side. I think that for this one it's going to go here and here. I think it's because of what do you call that, the positivity. So when your function, rational function is positive, it's going to acquire this 2 quadrant. And if your rational function is negative, it's going to be on this side and also this side. Okay, so let's have a look over here. Let's verify that. So this is going to be my intercept. And I can pick any value, for example. So let's say I'm going to pick a value of 1 right here. So let's see what happened to the function. So f of 1 is going to equal 2 over 1 plus 1. So that is going to equal 1. So my coordinate is going to be 1, 1. It's going to be up there. See? So the function, the graph is going to look something like this. Okay. And on this side, it's going to be like this. Alright, so the rule of thumb is going to be like this. So this is when you have a positive rational function, and this is when you have a negative rational function. So where it's going to occupy. So this one is going to be on the second and fourth quadrant. So when it's positive, it's going to be on the first and also the third quadrant. So unless it is a square function, for example, you have 1 over. Okay, so this one is not listed in one of my example, but because you have this in your workbook anyway on graphing square root function, so I'm going to give you an idea overview how is it done. So for example, what happened is that if you have a function which is in the form of fx equal square of g of x, so it could be plus and it could be also minus. If your function is a positive square root function, for example, let's say if you have something like this. So I have a function of f of x is equal square root of x minus 1, and it's a positive square root. So what happened is that my function is going to be positioned above the x-axis. The reason is that because no matter what value I substitute for x, remember for the smallest range it could be is going to equal 0. So my value could be from 0 until infinity. And because it's always going to be a positive number, and of course it's going to be from 0 until positive infinity, so it's going to be above because this is where positive y values are. Okay, so these are positive y values. And when I have a negative square root function, for example, negative of square root x plus 1, so because of the negative right here, so no matter what value I substitute for x, so the smallest value, the highest value is going to be 0, and it is going to be a negative value of y. So therefore, this is where it's going to be positioned. This is where all the negative y values. So bear that in mind, okay? For the case of square root function, you only need 2 elements in order just to sketch for the graph. You only need to find the domain, so where the graph starts, and the y-intercept. So that is the only 2 elements that you're going to need. So I'm going to show you by using this example right here. So I have a function of f of x equals square root x minus 3. Remember the domain for square root, when we have a square root, the limitation is that it cannot be negative. So my x minus 3 should be greater than or equal 0. Smallest value is going to be 0. So my x value should be greater than equal 3. So therefore, when you sketch, it's going to start from 3 until infinity. That is my domain. And where is going to be the intercept? So the intercept is going to be when y-intercept is going to be when x is equal 0. So when x is equal 0, so I'm going to have y is going to equal square root of 0 minus 3. So it's going to be square root of negative 3. And we know about square root of negative 3. So this number is a complex number. So therefore, what does it tell you when you have a complex number or undefined number? So it tells you that the intercept does not exist. It wouldn't cross at the y-axis. So that's the thing. So when I sketch, so the graph is going to look like this. Okay, and now it's a positive graph as well. It's a positive square root of x minus 3. This is going to be my x. This is going to be my function f of x. So where does it start? It starts at x equal 3. So that is why it doesn't cross the y-axis right here, because it's going to start at x equal 3. So therefore, when I sketch, so the function is just going to look like that. So that is going to be the graph of square root. The shape is always going to be like that. So either it's going to be, so if it's above the horizontal like this, it's going to be like this, or yeah, depending. So we don't want to be exact. We just want to have the idea of the shape. If it's underneath, so it's going to be something like this or like that and so on. Okay, so it's always going to be that curve. Okay, let me show you another one. So let's make up a function. So let's say if I have f of x is going to equal negative of square root of 2x minus 1. So the idea is still going to be the same. First, I'm going to find the domain. So 2x minus 1 must be greater than or equal 0. So what happened is that I will get x is going to be greater than or equal 1 over 2. So that is where my graph is going to start. No, I don't want this. I want it to start at negative. So let's change this to a plus instead. I won't need to have an intercept. I want to show you the case that we have intercepts. So let me change this. So I'm going to have a function of 2x plus 1 is greater than or equals 0. So I'm going to have x is going to be greater than or equal -1/2. And as for the intercept, so I will get that y is going to equal negative square root of 0 plus 1. So it's going to be negative square root of 1, which is going to be negative of 1. So when I sketch my function, so this is going to be the axis, this is going to be x, and this is going to be f of x. So my x is going to start at x equal -1/2. Let's assume it's going to be somewhere over here, and it's going to cross at 0, -1. So 0, -1 is going to be down here. So this is going to be the case because of the negative right here. So the function is going to be under the x-axis. So that's why when I graph, so this is how the graph is going to look like. You only need these two elements, and that's it.